In our last section, we talked about square threaded screws. Still stumbling over that one. So let's do an example. So I copied the picture in because I'm not that great of an artist. So this is a vise, right? The idea that basically we have a frame with a holder at the bottom, and then we have a screw that we can move in and out. And as we tighten the screw, we're going to put more force on our little object that we're holding here, right? And so we now want to know what is the moment to apply an axial force, of 5 kilonewton. And we're given that, maybe don't say given mu s, the friction coefficient is 0.5. The radius r is 1 centimeter. And the screw lead L is equal to 0.5 centimeters. So it's a pretty coarse thread, which is not that unusual for a vise. Now we're not given the thread angle, right, which is a thing that we need in our equation. So let's figure out what the thread angle is. Let's take one of those threads. A little hard to see here, right? But like the little one of these, and we can say, well, if we kind of plot them, if we unravel our screw, right, then we'll get a position that's going upward, 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 right? And we know that we've gone once around, right? So we go basically the diameter of the screw, so that's 2 times pi times r. And of course, as we're going once around, we increase, we go up or down, right, by the screw lead. So that means if this is our angle theta, then we can of course say that tangent theta is just going to be L over 2 pi r. All right, so we want to find out what theta is, so we can solve this for theta. Theta is then the inverse tangent of L over 2 pi r. In our case, inverse tangent of L was 0.5 centimeters divided by 2 pi times 1 centimeter. It doesn't matter if it's centimeters or meters here, as long as they're consistent. And that gives me an inverse tangent of 0.318, and that is 17.657 degrees. All right, so that's my theta. I also can convert my mu s to the friction angle. Right, I know that mu s is tangent of phi s. That means phi s is inverse tangent of mu s, and that is, let's write it out, tangent minus 1 of 0.5. And that is equal to 26.566 degrees. All right, I think now we have everything that we need, so we can just go in and say the moment would be the force that we want to have times the radius times the tangent of the friction angle plus the screw angle. So in our case, that'd be 5,000 Newton times, it was 1 centimeter, so 0.01 meters. And tangent, that doesn't fit, does it? Let's just write all this on the next line. Let's go back here. There. 5,000 Newton times 0.1 meters times tangent of phi s, we said, was 26.566 degrees, plus the screw angle 17.657 degrees. And if I calculate those numbers out, I get 48.66 Newton meters. So that's the amount of moment of torque that I would put on that screw head to make sure that I get that amount of force on my little blue block. Now, is the screw self-locking? Well, remember that we just have to look at the two angles. So in this case, yes. Because theta, I'm sorry, is less than phi s. Now, if we wanted to loosen the screw again, right? Remember, if it's self-locking, we'll have to add some moment to loosen it. So maybe say to loosen screw, we have to do our other equation. In this case, we have m is equal to F times R times tangent of phi s minus theta. Basically the same as what we had before, so 5,000 Newton, 0.01 meters times tangent of 26.566 degrees minus 17.657 degrees gives me 7.84 Newton times meters. So that's a result that makes sense, right? Because my loosening takes less force than my tightening. So overall, I think that makes sense. All right, so in this quick example, we looked at how much moment we would put on the screw head to apply a certain amount of force within our vise.